Well, check out this gorgeous view out of Edgeburg, Wyoming of the Aurora Borealis. Just early today and last night, we saw an incredibly powerful geomagnetic storm that arrived to Earth on Sunday, producing all of these stunning visuals, even as far south as Texas, California, North Carolina. We have a space scientist with the Space Weather Prediction Center with us right now, Dr. Mark Miesch, and thank you so much for joining us today, Dr. Miesch. Tell us a little bit about what caused this event.
Yeah, aurora are caused by explosions on the sun. So the sun, they are called coronal mass ejections. So the corona is the part of the sun that you see during an eclipse. It's the hot plasma atmosphere of the sun. And it can eject mass. It can, so a CME ejects mass from the sun. This one took about 2 days to go from the sun to the earth. So this was from a CME on Friday. And getting from the sun to the earth in 2 days isn't easy. It had to move at about almost 2 million miles per hour. But it got here and it arrived it peaked around midday on Sunday, but of course it was most spectacular in the nighttime when it became nighttime in North America, and we could see the northern lights. So this was a particularly big storm, and if the more energetic and the faster they're moving and the more mass in these CMEs, the more it disrupts the Earth's atmosphere, and we can see aurora at lower and lower latitudes.
And of course, it produces all of these very stunning visuals. What is it that, that makes the aurora happen whenever we have these coronal mass ejections?
Yeah, so this plasma, as I said, it's basically hot gas that's brimming with electricity and magnetism. And when it hits the Earth's magnetic field, so the Earth has a bubble around it, a magnetic bubble around it, and these CMEs come and squeeze and disrupt that magnetic bubble. And when that happens, it causes particles, mostly electrons and protons, to come raining down into the Earth's atmosphere. And the magnetic field of the Earth directs these particles to the northern and southern poles. But again, with particularly big storms like this, then that area of disruption near the polar caps can move to lower and lower latitudes. So when these particles from the Earth's geospace environment, the Earth's space environment, when they strike the atmosphere, they cause the molecules in the atmosphere to glow.
And so with the sun right now, we're heading towards something called solar maximum. Can you describe a little bit about what that is and what that will do to the aurora?
Yeah, so the sun goes through a cycle. It goes through a pattern of activity it increases in activity about every 11 years. And we are entering solar maximum. So we expect the magnetic activity to peak in the sun in 2024. And this peak corresponds to more magnetic storms. So more aurora, more other types of storms like solar flares are sort of flashes of light on the sun, energetic releases of X-rays on the sun. So these types of solar storms will become more frequent in the couple of years to come. And so it's a good time for sky watchers and aurora hunters. So if you're going to plan to go to high latitudes and see aurora, the next few years are a good time to do it.
Certainly. Now, the other side of this is there are some negative impacts to satellites, to the power grid. Can you tell us a little bit about what we can sometimes expect with that?
Yeah, so when these big CMEs come by and squeeze and disrupt Earth's magnetosphere, it can drive currents in power grids. And these can be disruptive to the functioning of a power grid. So the power companies keep a close watch on, we interact with them quite closely to keep a close watch on what the sun is doing. Large solar storms can also disrupt GPS navigation and radio communications. And they can cause problems for satellites. They can cause heating of the upper atmosphere, which causes drag on satellites and disrupts the navigation of satellites. So all of these things are potential impacts of geomagnetic storms, but this particular one this past weekend wasn't too disrupted. It was mostly a light show for us on Earth. Sometimes reports come in a little after the fact, but this particular storm didn't seem too disruptive.
Well, Dr. Miesch, thank you so much for joining us today, and thank you for all of that information. I hope to have a lot more good light shows over the next several years. In the meantime,
Yes, thank you.
we have a lightning show ongoing across parts of Florida. Meteorologist Bon Sharifi has more.
Yeah, we bring you out to Viper radar, where we are tracking thunderstorms working through the region. We've got several severe thunderstorm warnings across the area and, well, a lot of lightning associated with these storms here as well. So looking at the state, we've got things on a loop over only the last 30 minutes, and you can notice hundreds of lightning strikes over that time frame. Severe thunderstorm warnings are ongoing across portions of Deltona. That's going to include Seminole County, Florida, down through Polk County, Florida, through the city of Lakeland, and down through Fort Meade and Polk County as well. Several of these severe thunderstorm warnings, they have already had that tornado possible tag. These ones in particular closer to Fort Meade are for 60-mile-per-hour winds, 1.5 inch in diameter hail. This one out into Lakeland is going to be, well, lots of lightning, but also 1 inch in diameter hailstones, 60-mile-per-hour winds. And then this one over here also going to be for those 60-mile-per-hour winds, 1 inch in diameter hailstones crossing that I-4 corridor. Stick with us here on Weather Nation. We'll continue to break down all your top weather headlines along with your Western Regional next.